Is our universe truly one of a kind? Modern physics is grappling with a fascinating puzzle. If string theory is correct, it requires the existence of extra dimensions beyond the three we see. But is there any real-world evidence that these hidden dimensions could create other universes with different laws of physics, or even affect our own reality in ways we can measure? It all started when scientists were trying to understand the forces inside an atom's nucleus. They quickly realized that a universe with just three spatial dimensions wasn't enough for the math to work. For the vibrating strings of string theory to account for all the particles and forces we know, they needed more room. This led to an incredible idea. Our universe might have 10 or even 11 spatial dimensions, most of them hidden from our view. The most mind-bending prediction is that these extra dimensions aren't just a mathematical trick. Their specific shapes and structures could give rise to a multiverse. Each universe in this cosmic landscape could have its own unique physical laws, its own values for fundamental constants, and maybe even different kinds of matter and energy. If this is true, it might explain one of the biggest mysteries of all: why our universe seems so perfectly fine-tuned for life to exist. A huge breakthrough came in the mid-1990s during what's known as the second superstring revolution. Physicists like Edward Witten discovered that all the different versions of string theory were actually just different perspectives of a single, unified framework in 11 dimensions called M-theory. This theory introduced new objects called branes, short for membranes, that are deeply connected to these extra dimensions. Suddenly, the old limitations vanished, and the focus shifted from subatomic forces to the unseen architecture of space-time itself. So, where are these extra dimensions? The leading idea is that they are compactified, curled up so incredibly small that we can't perceive them. Imagine a garden hose. From far away, it looks like a one-dimensional line. But for an ant walking on it, it has a second dimension: the circumference it can walk around. Our extra dimensions could be like that, just on a scale billions of times smaller than an atom. By playing with the mathematical shapes of these tiny, curled-up dimensions, physicists can simulate different universes, each with its own set of physical rules. And this isn't just theory. These principles are already guiding the development of new technologies in particle accelerators and quantum computing. Beyond just theoretical physics, the journey into string theory has given us powerful new mathematical tools. Concepts like mirror symmetry, which were born from studying these extra dimensions, have solved long-standing problems in pure mathematics. But more than that, they've found their way into the real world. These mathematical insights are now used to model the properties of advanced materials like superconductors and nanomaterials, which are essential for future technologies. Believe it or not, the math inspired by extra dimensions is already shaping our lives. In medicine, holographic techniques derived from these principles are helping create detailed, higher-dimensional maps of biological tissues. In material science, the equations of string theory are helping engineers design materials like graphene and high-temperature superconductors. These are the building blocks for the next generation of electronics, transportation, and medical diagnostics. Even aerospace engineers are using insights from extra-dimensional dynamics to design stronger, more efficient spacecraft for exploring our solar system and beyond. What this all points to is a radical new understanding of reality. String theory suggests that the fundamental laws of our universe, gravity, electromagnetism, the quantum forces, might not be so fundamental after all. They could be local rules that emerge from the specific geometry of our universe's hidden dimensions. If you could change that geometry, you might create a new universe with entirely different physics. Right now, scientists are actively hunting for proof. They're sifting through data from particle colliders, analyzing cosmic radiation, and studying gravitational waves for any sign of these hidden dimensions. While direct smoking gun evidence is still out of reach, the quest itself is pushing the boundaries of what's possible. The story of string theory is not science fiction. It's a real story of innovation, powerful new ideas, and a deeper understanding of existence. The bold prediction remains: future discoveries about the geometry of our universe could unlock a reality far grander and more diverse than we ever imagined. Thanks for watching. If you enjoyed this journey into the fabric of reality, be sure to like, subscribe, and hit the notification bell for more deep dives into science.